Chapter 8, Section 3. This section discusses earthquake hazards. Earthquake-related hazards include seismic shaking, liquefaction, landslides, mud flows, and tsunamis. It's more than just the ground opening up like we see Hollywood depict a lot. There are multiple other things that can result from earthquakes. Seismic vibrations, also called seismic waves, can damage buildings and other structures from earthquake waves, depending on several factors. These factors include the intensity and duration of the vibrations, the nature of the material on which the structure is built, and the design of the structure. In other places, not here in the Midwest, they have to build their buildings to withstand earthquakes. They have to be able to withstand seismic vibrations. Here we have a picture of a building that was built not meeting their standards, and a little bit of shaking caused it to collapse in on itself. Whereas the building right next door with just as much glass is left standing with no issues. Factors that can determine structural damage include the intensity of the earthquake, whether or not they used unreinforced stone or brick buildings, because those can cause the most serious safety threats. The nature of the material upon which the structure rests, if it's a sand or a clay, once it starts shaking, those types of materials are not going to hold up very well. And then lastly, the design itself of the structure. If it's top heavy, is it going to tip over? Liquefaction is this phenomenon in which saturated material, so if it's full of water, it's saturated material, it's actually going to turn into a fluid. So not like a mud flow, but it's shaking so much that it actually turns it into a liquid type substance. And when that happens, underground objects can float to the surface. It may be big rocks, it may be chunks of something that was buried long ago, but those can also pose serious dangers and threats to people. The liquefaction can also cause these sinkholes to form, and they will swallow up a whole building. Some other dangers include landslides. With many earthquakes, the greatest damage to structures is from the landslides in the ground subsidence, or the sinking of the ground triggered by those vibrations. Fire is another big danger we don't often think about that goes right along with earthquakes. But in the San Francisco earthquake of 1906, most of the destruction was caused by fires that started when gas and electrical lines were cut. Buildings started falling down, and the firefighters at the time could not get to the buildings that were on fire to put them out. And if you think back to 1906, there were a lot of wooden structures. There weren't a whole lot of stone and brick and concrete and steel. Another threat comes from tsunamis. Again, here in the Midwest, we're not familiar with this, but if you live anywhere around the Pacific Ocean, this is something that you probably hear a lot about. A tsunami is just triggered by an earthquake occurring when a slab of the ocean floor is displaced vertically along a fault line. So essentially it's an earthquake at the bottom of the ocean. Tsunamis can also occur when the vibration of the earthquake sets an underwater landslide into motion. And tsunami is just the Japanese word for seismic sea wave. Here we can see, this is going to be on your worksheet that you get as well, but you can see the displacement occurring and then the waves traveling out. Out here, the tsunami is traveling very, very quickly because there's not a lot of anything to slow it down. There's not a lot of friction. As the water starts getting shallower, as we get closer to shore, the tsunamis are going to lose speed because that friction from the bottom of the ocean is going to slow it down. But when that happens, the wave height will actually increase, so that amplitude. And here the water depth is 20 meters, the tsunami speed is slowed way down, but the wave height, that crest height, is much higher than it was out here. So if you were in a boat out here in the middle of the sea, that tsunami may be traveling 835 kilometers per hour, but you wouldn't notice it. Whereas if you were here, those 50 mile an hour wave or 50 kilometer per hour waves that are way higher than any boat you're going to be on, you definitely notice it here. The parts of a wave, again, this is going to be on your worksheet, so you might want to take note of the differences in terms. We have the trough, which is the bottom of the wave. The crest is the top. The distance between crest to crest or trough to trough is called a wavelength, so from point A to point B. The wave height is the distance between the crest and the trough. The frequency is the number of wave crests passing a point each second. And then the period, the time it takes for the wave to crest at point A to reach point B. So all of those things you're going to need to know for that worksheet. If it sounds familiar, it probably should, because I'm sure that you learned about waves in middle school. We talk about waves when we deal with light and energy traveling. So back to the tsunamis. There's a tsunami warning system set up. Large earthquakes are reported to Hawaii from Pacific seismic stations. Here on this map, you can see all these little blue dots. Those are the sensor stations that they have setting at the bottom of the ocean. Although tsunamis travel very quickly, there's sufficient time to evacuate all but the area closest to the epicenter. So if you had an earthquake right here, you would have a few hours before it got to Japan and give you time to evacuate. If the earthquake happened here in Indonesia and you were in Chile, you'd have plenty of time to evacuate, or even Hawaii. You're also going to have another worksheet that deals with tsunamis and their wave travel time. So remember, here's Alaska up here. We've got quite a few sensors up here that could tell you how long that wave is going to take to get across the Pacific. Earthquake damage and loss of life can be reduced by determining the earthquake risk for an area. We can build earthquake-resistant structures like they do on the coast, and we can follow earthquake safety procedures. You may have done an earthquake drill in elementary school. Here in Missouri, we oftentimes forget about the New Madrid fault, but it's a very serious, very real threat. And so if you are in an earthquake, if it's a serious earthquake, the safest place for you to be would be under a desk at school, something to protect you from things falling on your head. The earth is probably not going to open up and swallow you like on TV, but you would be in danger from things falling from the ceiling, like the roof tiles, anything that's up in the ceiling that could fall on you, bricks, things like that from the building itself. If you were outside in the middle of a field, you're probably pretty safe. There's not much that could fall on you. But if you're in your house at home, you're probably not going to have sturdy desks like we do here. And your safest place there would be to get to a door frame, because those are usually well reinforced and would provide you a little bit more protection. Predicting earthquakes. Short-range predictions methods so far have not been very successful. We really don't understand that much about the earth to be able to predict when is it going to have a hiccup. When are we going to have earthquakes? When are we going to have these shaking events? Long-range forecasts. We still don't understand enough about how and where those earthquakes are going to occur to even come close to making long-term predictions. You very well may have heard people talk, though, about how Yellowstone is a supervolcano and we're going to have earthquakes out there. We'll have earthquakes. We're due for the New Madrid fault to have another earthquake. And that's just based off of the intensity of the last time that we had earthquakes in those places. And it's just been so long since that's happened, scientists think, well, we must be due for another one. A seismic gap is an area along a fault where there has not been any earthquake activity for a long period of time, much like New Madrid, Missouri, which is down in the Boot Hill. You have an article that you will read in class about the quake that happened in New Madrid. It's also the reason we have the Boot Hill as part of Missouri.